piecewise defined functions. Hold on, let me move that mic a little bit. Probably gonna hear a lot of noise there. Okay, so piecewise defined functions. Okay, it sounds a lot more horrible than it actually is. When you're talking about piecewise defined functions, you're talking about something like this. So you have the function notation, which we discussed in the first section of this unit, and then it's broken into pieces, hence the word piecewise. Okay, so I've got two pieces here. So what it's saying is my first piece is going to be 2x plus 3, okay, but only if my x values are less than or equal to 0. The other piece would be that I'm going to use negative x minus 1 if x is then greater than 0. So you've got these two parts, okay, and this right here is called my parameters, or you'll hear me call them boundaries. They're actually parameters, but sometimes it's helpful to think of them as being a boundary. So 0 is going to be that boundary. I'm going to have a piece to the left of the boundary and a piece to the right of the boundary. Okay, so if I want to evaluate, okay, so evaluate f of 2, f of negative 6, and f of 0 for the function f of x equal to, and those two pieces that we just mentioned. Okay, and then they want us to write our results in ordered pair form. We've already discussed this and how to do this in the first section. So if I want to do this, I need to look at the parameters itself. Okay, so again, I'm using this piece when x is less than or equal to 0. So if I'm looking at f of 2, okay, remember the number inside of the parentheses, this is my x. So essentially what I'm saying here is that x is 2. Okay, so x is going to be the 2. Well, is that less than, greater than, or equal to 0? 0 because that's what my parameter is. This, of course, is greater than 0. So since I'm looking at an x value greater than 0, I need to use the defined piece that has an x value greater than 0. So here I'm going to use the negative x minus 1 piece. Okay, I'm going to use the negative x minus 1 piece because it's the part that has x values greater than 0. Now to actually figure that out, this is just determining which piece to use. Once I know what piece to use, it's just a matter of plugging it in. So f of 2 is equal to, now I'm going to use negative x minus 1, and I'm just going to replace that x with my new x value. Okay, it's a substitution, so negative 2 minus 1, which is negative 3. Now the very last step is we want them in ordered pairs. Okay, so this is my x, this is my y, so as an ordered pair it would be 2 comma negative 3. Okay, 2 comma negative 3. So that's the very first one. Now that's just one of them. They want me to do negative 6 and 0 also. So here we go. So if I'm looking at f of negative 6, okay, negative 6 is the x that I'm working with. Well, that's going to be less than 0. Okay, so if my x value here is less than 0, going back to my function, I have to figure out, do I use the top one or the bottom one? Well, on the top, that's where my x values are less than 0. So I'm going to use the top one for this particular number. So 2x plus 3 is the function that I'm going to use. Okay, so f of negative 6 is equal to 2 times negative 6 plus 3, which is negative 12 plus 3, which is equal to negative 9. Okay, so negative 9, write it as an ordered pair, which means x is negative 6 and y is negative 9. What I plug in is my x, what I get out is my negative 9. It's that whole independent, dependent variable stuff. Probably remember that back from Algebra 1. Okay, so then last one here, f of 0. Okay, so now we're looking at one exactly on my boundary. So here we're looking at 0 is equal to 0. So which one do I use? Do I use the top one or the bottom one? That's the question I'm asking myself. Well, here, remember that a line underneath, we did this in the inequality section of in the first semester. So if I have a line underneath, that means equal. Okay, so here would be x is less than or equal to 0. So this is where it's equal to 0. So we're going to use that top one again, 2x plus 3. So then we're going to do f of 0. So I'm going to take that 0, plug it in for x. So 2 times 0 plus 3, which is just equal to 0. My ordered pair would be 0, positive 3. And that's my 3 different coordinate points or ordered pairs. Okay, 3 ordered pairs to go with this one function. Okay, there's another one here. Same sort of idea, it's just a little bit more complicated, not even much. Here I've got 3 pieces, okay, which is perfectly fine. I've got 3 pieces. This piece is for anything less than 0. The middle piece is for anything equal to 0. And that last piece is anything greater than 0. Okay, less than 0 equals 0, greater than 0. They're not always going to be 0, although in our examples that we're going to do today, they are all equal to 0. But my parameter can change. My boundary here can change. Okay, so they could all be 1s. They could have all been -2s. Okay, this thing can change. It just depends on the problem itself. So keep that in mind that they're not always going to be 0. Okay, these ones are 0 though, so we're going to go from there. I'm going to kind of skip this left-hand side. This left-hand side is just a matter of figuring out which piece to use. We're kind of just going to talk about which piece to use now. I'll write down a little bit, but we're going to save ourselves from having to write all that stuff. So, f of 0, let's do that one first. Okay, so my x value is 0, so I have to figure out is it in the top, middle, or bottom. Okay, x is 0. Well, x equals to 0 is the middle piece. It says so right there. If x is 0, use x plus 3. So we're going to do that. Okay, so we're going to use the x plus 3. This is an arrow, by the way, if you're wondering what that was. It's just a little arrow. F of 0 yields x plus 3, which yields it. I'm just kind of, train of thought is kind of what I'm working with here. That's why I'm using arrows. So, plug in a 0 for x, so I get 0 plus 3, which is just 3. Okay, so when x is 0, y is 3. That's your first one. Okay, move on to the next one, f of -3. Okay, so when I've got f of -3, so my x value is negative. Okay, so top, middle, bottom, that's what I'm asking myself. Is -3 less than 0? Of course it is, so I'm going to use the top piece. So I'm using that x squared minus 2. Okay, so I'm going to plug -3 in for x. Make sure you use your parentheses here because you have to square the entire -3, not just the 3. Minus 2, which -3 squared is positive 9 because a negative times a negative makes a positive. And then minus 2 equals 7. So I've got when x is -3, y will be 7. Ordered pair. One more to do here. So f of 5. Okay, 5 is positive. Is it less than 0? No. Is it equal to 0? No. Is it greater than 0? Of course 5 is greater than 0. So I'm using this piece now. Okay, so I've got the square root of x is my function that I'm working with. Now we need to plug a 5 in there. So the square root of 5. Now we don't want to do a decimal here and then just round because that wouldn't be accurate. We want an exact answer. Okay, we want exact answers. So in order to get exact answers, you can't do decimals and then round them. You have to just leave the square root of 5. So my answer here would be when x is 5, y is just the square root of 5. Okay, and that's only because there is no perfect square in 5. And the decimal for this is going to be something that you're going to have to round, and we don't want any of that. We don't want you rounding because then it is no longer exact, and we like exact answers. Okay. At this point, I would suggest that you go ahead and hit that pause button. Okay, see what you can do, see if you can get the same answer I do. I'm going to keep on going with these, and when you come back, check your answer with mine. So, moving on for us, if you have f of 4, okay, that's going to be 4 is greater than 0, so I'm going to use the one where it says greater than 0, which is this bottom one, x plus 1. That's the piece that I'm using. So when I plug in the 4, I get 4 plus 1, which just equals 5. So the ordered pair is 4, 5. Now you may hear me say ordered pair or coordinate point. They're kind of the same thing. So ordered pair, coordinate point, I mean the same thing. I'm looking for this right here. It's a point on the graph. Alright, so then f of -2, same sort of thing. -2, that is less than 0. x is less than or equal to 0, so you need to use the top function this time, negative 4x minus 2. Okay, plug in negative 2, negative 4 times negative 2 minus 2. Negative 4 times negative 2 is positive 8. 8 minus 2 is then 6. So my final answer here would be x is negative 2, y is positive 6. Got 2 down, 1 to go. Okay, so the last one here, f of 0. So here, this first one, less than or equal to 0, that line means equal to, so we're going to use that first piece again, negative 4x minus 2, which then leads to plugging that 0 in, negative 4 times 0 minus 2. Negative 4 times 0 is just 0, so 0 minus 2 is a negative 2. Okay, so our coordinate point here, x is 0, y is negative 2. And there's all three. So hopefully this part isn't too bad. It's just a matter of really figuring out which piece to use. Okay, so wherever your x lies within those parameters, if it's in the first one, second one, sometimes there's a third one if you look at the one before, just find which piece you're supposed to be using and then you just plug in your x value, get a coordinate point out. Now we also have to be able to graph these things. So when we graph them, the same sort of concept is happening here. Okay, if I want to graph this right here, it's going to be graphed into two separate pieces, hence the word piecewise, right? So I've got these two pieces. Well, this piece only occurs when x is less than or equal to 0. So that's going to be from 0 to the left. So looking at my graph, that's going to be over here on this side, 0 to the left. Okay, because this is where all of my x values are less than or equal to 0. And then for this piece, it's going to be on the right when x is greater than 0. Okay? So open and closed dots, we did these when we did inequalities. Please keep in mind that when you have a less than or greater than, that means open dot, because that means that point is not included. So for instance here, if x is greater than 0, it is not included. Okay? 0 is not included, but we are going to have to graph it because we want to see what happens all the way up to the boundary point. And I'll discuss that more in just a second when we start to graph this one. Okay, but the line underneath, if we have less than or equal or greater than or equal, you have to have closed dots because that means it is included in my set. So, one thing that you have to have when you go to graph these, whatever your boundary is, needs to be part of both graphs. Okay, and you might want to make a note of that. The boundary needs to be part of both pieces. Needs to be in both pieces. Okay, it needs to be in both pieces. It has to be in both pieces because we have to see what's happening at the boundary. Okay, so when we go to put this in here, if x is less than or equal to 0, we use the 2x plus 3. That's what our parent function up here sets, or our piecewise function sets. So when I pick my x values, I'm going to start with the boundary for both. Okay, 0 is my boundary, so I'm going to start with my boundary for both. If this is 1, you need to start with 1. If this is 2, you need to start with 2. Hopefully you get the point there. Okay, whatever these numbers are, that's where you need to start. Now, figure out which one's open and closed first. That tends to be easiest. So here we have the equal sign, so this one is closed. Here, this one is not equal, so this is going to be open. Okay, and then let's finish picking all of our x values, and then we'll actually plug them in. So when I go to pick these x values, yes, I can pick any value I want, just like we did in the very first section of this unit. I can pick any value I want. However, this has domain restrictions. I have to pick ones that lie within the parameters. So this says x is less than or equal to 0. So I don't want to put in 2. Because 2 is not less than 0, so that doesn't work. I have to pick numbers less than 0. Okay, so just at random, -1 and -2, those are both less than 0, so those would be fine. Coming over to this side, I'm looking at numbers that are greater than 0. Okay, and yes, I know 0 is not actually included in this set, but that's why we use the open dot. But you have to start with the boundary. Okay, and then I just want 2 more points bigger than 0. Okay? 1 is bigger than 0. 2 is bigger than 0. I can use different numbers here. I could use 5 and 9 or 11 or 15 or 723 if I really want to, as long as it's greater than 0. That's all that matters. Okay? Time out. My screen froze yet again. At least one per lesson. It's got to do that. Okay, so now I've picked my x values. My x values fit within my parameters. Okay, x values here, they are all greater than 0, so they fit within my parameters. Now I plug them in using the function it says to use. So here, 2 times 0 plus 3, which is 3. So when x is 0, y is 3. Do that for each one. So 2 times negative 1 plus 3. Negative 2 plus 3 is equal to positive 1. So when x is negative 1, y is positive 1. 2 times negative 2 plus 3 is equal to, this is negative 4 plus 3, which is negative 1. So when x is negative 2, y is negative 1. Okay, so do the same thing for the second piece. Okay, only now I'm going to use the equation or the function for the second piece. So negative 0 minus 1, which is negative 1. Negative 1 minus 1, which is negative 2. And negative 2 minus 1, which is negative 3. So when x is 0, y is negative 1. When x is 1, y is negative 2. And when x is 2, y is negative 3. Okay, so I've got my chart or my x, y values, whichever way you want to think about it. Okay, my x, y values here. X, y values, we're going to plot them. Okay. So here we go. When x is 0, y is 3, and that is a closed dot. Closed again because this thing says equal, because it's got the equal, it's got the line underneath. Line means closed. Okay, then when x is negative 1, y is positive 1. And when x is negative 2, y is negative 1. Okay, so those are my dots. Don't just draw dots. These are graphs. I could have chosen any x value I want to, so they're going to go to the left. Now please note that I only went left. Notice I didn't go right. Okay, I call these boundaries for a reason, because 0 is my boundary. So this first piece has to be less than 0, which means it can only exist on the left-hand side here. I can't go to the right, because now I'm encroaching on this guy's boundaries. This guy's got the x is greater than 0, so I can't encroach on that. So this guy goes from the boundary to the left. The only side that has the arrow on it is the side to the left, because this thing will continue forever to the left, but it stops right here. Okay, it stops right here because this says x is less than or equal to 0, and that's it. Can't go into x is 1 or 2 or 3, because those don't fit in that parameter. Okay, so now next one. When x is 0, y is negative 1. And that is an open circle. Open because it's not equal to. There is no line underneath, so open. X is 1, y is negative 2. And x is 2, y is negative 3. Okay, and then draw that line. Okay, so here again. First of all, notice that I went from the boundary to the right, and then I drew my arrow. Okay, from the boundary to the right, I drew my arrow. I did not encroach on this guy's territory by going over my little boundary line. Okay, I came all the way up to the boundary, and that's it. Now, the boundary line they share. That's the only place they will ever meet up or match up or anything like that. Other than that boundary, they will never cross. If they cross, you messed up. Go back, do it again, okay? Probably chose the wrong x values would be my guess. You didn't choose values within your parameters. Okay, so they shouldn't cross other than right there at that boundary line. Now notice even there they still don't cross. I have one is filled in, one is not filled in. So they really don't even share that same point. Okay, up here if I got to 0, I would jump to this graph and use this graph over to the left. Okay, a few more things I want to point out before we move on and do another one. The only open circle I have is on the boundary, because x is not equal to 0 here. So 0 has to use the open circle to show that it's not actually in the set. everything else is filled in because x is 1 is in my set. X is 2 is in my set. So all of these are going to be filled in circles. Everything to the right here is filled in. The only one that will be open is actually on the boundary. Okay? The reason why we have to go to the boundary and we don't just stop at 1 is because then we don't include all the stuff from 0 to 1, like 1/2, 1/4, 1/8. All of those stuff are technically greater than 0. So we do have to include all those. That's why we go all the way up to the boundary, okay, and we just don't include the actual boundary point. That boundary point is owned by this other graph. Okay, so that is that first one with the graphing. So I'm going to show you another one. It's got a little bit more difficult graphs, but nothing too horrible. We will talk about which proper x values we need to plug in for that, okay, which we did talk about in the first unit as well, but we'll talk about it again. Okay, so here they didn't set up my cute little tables like they did here. Here they had it all split out and ready to go. Here I'm going to have to make it up for myself, which is how your test is going to be. Okay, so I've got x plus 5 if x is less than 0. So when x is less than 0, I've got x squared plus 5. And I'm going to make an xy chart so I get x values and y values. I'm going to do the same thing over here for the other part. So when x is greater than or equal to 0, because that's what it says, we're going to use the square root of x minus 2. Okay, so when x is greater than or equal to 0, square root of x minus 2, and I'm going to have an x, y chart for this one also. Okay, I need to pick at least 3 points for each one. You don't have to do all 5 for the simple fact that it's a piecewise. You can split it 3 and 3 is fine. Okay, so picking values here. Okay, I know without a doubt 100% since 0 is my boundary, that should be in both. Okay, it's always a good place to start so you don't forget them. Here, this is not equal, so this is going to be my open. This one is equal, so this is going to be my closed. I like to just mark those so I don't forget about it. Otherwise, I forget which one was open and closed. You can always go back and look, but sometimes it's just nice to have it all written out for yourself so you don't forget to leave one of them open. Okay, now, x is less than 0. So I'm going to pick numbers less than 0. So I'm just going to go -1, -2. Doesn't have to be those numbers. I can do -3 or -7 as long as it's less than 0. Plug those in. So 0 squared plus 5 is 5. -1 squared plus 5. That's 1 plus 5, which is 6. And then -2 squared plus 5. -2 squared is 4. 4 plus 5 is 9. Same thing for the second piece. Plug that in. The square root of 0. Oh, wait. First I got to pick my points, right? So x is greater than or equal to 0. So I've got 0. And I'm just going to do 1, 2, because that's typically what most people are going to do. And we're going to talk about some better choices in just a second. So if I did 0, square root of 0 minus 2, square root of 0 is 0. Minus 2 is -2. Okay, so the next one, if I do 1, the square root of 1 minus 2, the square root of 1 is 1, minus 2 is -1. Now 2 is what most people want to do because they like to go in order, 0, 1, and 2. But if I do the square root of 2 minus 2, well, there is no perfect square of 2. So the square root of 2, I'm going to have to find some awesome decimal, 0.8 something something, and then subtract 2 from it. Okay, and then I'm going to have to try to graph that. I don't want to try to graph that. So I'm not going to use 2 because it's going to give me a decimal, and I don't want to try to graph decimals. What I'd rather do instead is find an x value that gives me perfect squares. So if instead of doing 2, I did x is 4. Well, now I've got the square root of 4. I'm going to do it right here. The square root of 4 minus 2. Well, I can do that. The square root of 4 is just 2 minus 2 is just 0. That's a lot easier. So when you pick your x values, pick x values that are going to plug into these square roots nicely. Perfect squares. 0, 1, 4. If I wanted to pick another one, I'd pick 9. Okay, because then the square root of 9 would be 3, and 3 minus 2 would be 1. So nice, easy numbers to graph. Okay, so time to graph. So when x is 0, y is 5, x is 0. This, by the way, is the x-axis. This is the y-axis, just in case we forgot. Okay, so x is 0, y is 5. 1, 2, 3, 4, 5, and it's open circle. Okay, open again because it does not have an equal sign. And then x is -1, y is 6. Only the one on the boundary is going to be open. Everything else is closed. And then -2, +9. So when I connect these, should look like half of a U here, because this is a quadratic that I'm working with. If you've studied your parent functions like you should, then you know that it's supposed to be a U. I just can't see my whole U, because in order to get the rest of the U, I would have to go into this guy's territory. Okay? These are highly territorial people. You don't want to do that. You might start a war. You never know what would happen. Stay out of their land. Okay? It stops at the boundary, which is 0. Same thing over here. So when x is 0, y is -2, 1, 2. That is a closed circle. Okay? When x is 1, y is -1. And when x is 4, 1, 2, 3, 4, y is 0. And I said if I chose to put 9 in there, I would get 1. When x is 9, y would be 1. Okay? That's just a little extra point because I like my graphs to be pretty. The more points, the prettier they get. Sometimes. Okay, so there would be my graph. So just to kind of recap just a little bit, this one, open circle on my boundary, goes to the left, has my arrow. Here, closed circle on my boundary, goes to the right, has my arrow. Nothing is overlapping. The only place they meet is on the boundary, and one is closed, one is open. Okay? One will always be closed and one will always be open. The only way that could ever even be different is if there are 3 pieces, and then I would have open, open, and closed. Okay? If it's a function. If it's not a function, that's a whole different story, but we're not going there. Okay? So make sure these things are not overlapping each other, and that the only place they even meet up is on the boundary. One is there, one is not. If you have to, think about a war. This is this guy's territory. This guy can't be here. All of this stuff belongs to this guy. All of that stuff belongs to that guy. He can come up to the border, but he cannot step his foot on that border. Okay, so at this point I would highly suggest that you hit the pause button. Go give this one a try. Come back, see if you got the same answer as I do. Okay, I'm going to go ahead and work this one out. So starting with setting up my little graphs and stuff, x is less than or equal to 0, we use 3x plus 2. When x is greater than 0, we use -x minus 1. Okay, xy for this one, xy for this one. Okay, those are my little t-charts. Pick my values. I've got 0 in both, so the 0 has to be in both. Go from there. Here, x is less than or equal to 0, so this is closed, which makes this one open. Here I'm looking for less than, so -1, -2. Here, I'll even just do, I'll do -3, just to change it up and show you that it can be different. You don't have to do 0, -1, -2. I can do -1, -3. Okay, let's do the same thing over here. So greater than 0, so 1 and 2. Plug those values in. 3 times 0 plus 2 is 2. 3 times -1 plus 2, that's -3. Plus 2 is -1. 3 times -3, that's -9. Plus 2 is -7. Okay, do the same thing on this side, so plug that in. -0 minus 1 is -1. And we've kind of already did this up above, so if you want to just copy that t-chart, it's going to be the same. -1 minus 1 is -2. And then -2 minus 1 is -3. Alright, so here we go. Let's graph this thing. So when x is 0, y is 2, and that is closed. When x is -1, y is -1, and that is closed. And then I skipped over to 1, 2, 3. When x is -3, y is -7. 1, 2, 3, 4, 5, 6, 7. Okay, so that would be my graph down to the left. There's my arrow, stops on my boundary. If you chose -2, 1, 2, you would have found that it was 1, 2, 3, 4. I believe x is -4. Okay, if I would have decided to do -2, I'd have gotten -6 plus 2, which would have been -4. Notice how it fell straight on that line. So it's not any different. If I choose -1, -3, -2, they all end up on that exact same line. It's the beauty of drawing these graphs. Okay, it is a straight line. We know that it is because this is linear. If you're studying your parent functions, there's just an x, no square roots, none of that stuff. So it's just a straight line. Okay, so doing the other part, when x is 0, y is -1, and that's an open dot. When x is 1, y is -2. And when x is 2, y is -3. So we should have this nice, pretty little line. It is a straight line. It goes down and to the right. Okay, so we've got this piece, which is kind of hard to see on the screen. Let me darken it. Goes up to the boundary, starts at this boundary. Okay, you should always be ending and then starting again at a boundary. End at a boundary, start again at a boundary. That's kind of how this game works. Okay, that's what makes them functions. They should pass the vertical line test. They are functions. Okay, so anywhere I draw a line, they should only hit one part of the graph. Here, remember, it only actually hits one part because this is an open circle, so this doesn't really exist at 0. So keep that in mind when you're going through these. If you get anything different, try again. All right, good luck.